Hello friends, myself Dr. Jugal Kishore. I am going to take the subject electronic instruments and measurement. So in this particular subject, it's divided into four units. Unit 1 is just introduction about the metering. In this particular unit, we have studied about the performance characteristics of the instruments, error of the instruments, and then basic meter movement. It means the movement of the pointer in the instruments. Then we have also studied about the different type of the display devices, for example LED, LCD, and our digital display indicators. Then we have also studied about the classification of the printer, for example drum printer, dot matrix printer, inkjet printer, and the laser printers. And at the last we have studied about the different electrical standards and its calibration. Then after this unit 1 we move to the unit 2. Is the unit related to the basic instruments. It's a cover DC emitter, DC voltmeter, AC emitter, AC voltmeter, and then the digital voltmeter. After this unit, we have moved to the unit 3. Unit 3 covered about the cathode ray oscilloscope. Here we have studied the basic principle of the cathode ray oscilloscope, its features of the cathode ray oscilloscope, its block diagram of the cathode ray oscilloscope, then the digital storage oscilloscope, optical fiber fiber optic CRT recording oscilloscope. And at last we have studied the fourth unit. This particular fourth unit is all about the electronic instruments. In case of electronic instruments, we have studied about the AF oscillator, signal generator, function generator, and then frequency selective and heterodyne wave analyzer, digital data recording, potentiometer recording, then the waveform recorder, and at the last we have studied about the different type of the transducer, data acquisition system, and then the digital acquisition system, then multi-channel DAS. The textbook for this particular subject is A.K. Sahani, Electrical and Electronics Measurements and Instruments. The publisher is Dhanpat Rai and Sons, and the second book is H.S. Kalsi, Electronic Instrument, and publisher is Tata McGraw-Hill. In this lecture, mostly we have read for HS Kalsi, Electronics Instrument and Measurement. In the some cases, we have moved to the AK Sahni. So then we have go for the unit 1 part. So we already know that unit 1 is all about the instrumentation. So that's then the what is the electronic instrumentation. So the basically instrumentation is a technology of the measurement. How a measurement will the perform, because the measurement is actually a science. It is this is the very big it itself is a science. And measurements is different upon the knowledge of the parameters. This depends on the instrumentation. So basically, in case of the measurement, we used to monitor a process or operation. It means basically measurement is a monitor a process or operation, or as well as the controlling process. For example, we are using the thermometer. For thermometer that is used for the measurement of the fever. But what is the process? It actually measure the variation of the temperature, and we know what is the standard value of the temperature. After that we call it a fever. So when we measure it, we use a thermometer to measure our body temperature, and after the measured data we are able to conclude that this particular person is suffering from fever or not. So the thermometer is basically a instruments. Similarly, if you want to know the what are the process or operation, so the process and operation is measurement is used to actually measure the temperature. Similarly, we have seen here the way I mentioned the example one. It's to have the thermometer, it's have the barometer, it's have the anemometer are used to indicate the environmental condition. It means a thermometer is also used for environmental condition, but is the design is depends upon the application for the measurement of the fever of particular person. We see that a different type of the thermometer for a measurement of environmental condition. We see a different type of the thermometer, but the basic process is the same in all the cases. Similarly, in our daily life, we have seen the water meter, gas meter, electric meter. What are they basically used? They used to define how much quantity of the water we have used, how how much gas we have used, or how the electricity we have, how much electricity we have to consume. It means these meters are used to keep track of the quantity of a commodity. It because the water, gas, and electricity is a commodity, and we are going to use. So, how much quantity of this commodity we have used is you to track the how much quantity of a commodity we use. We use gas meter, water meter, and electric meter. Similarly, a selection of the basically instruments depend on what is available and the performance of the equipment render itself for the job to be performed. Just I give the example, a thermometer that is used to indicate the environmental condition. So basically this particular thermometer is a equipment that render itself for the job of measuring a temperature. Then we have to decide what are the applications the thermometer used for the measuring a temperature of a particular location, or it used for the measuring a temperature of a body. So these are the basically introduction of what are the instrumentation. So if we conclude that conclude this whole topic, so instrumentation is a technology of the measurement, and knowledge of the parameter depends on the instrumentation, and measuring is basically used to monitor a process or operation, or as well as the controlling process. Then we move to the next topic. What are the basically concern of the instruments? If we use a instruments for a particular measurement, our concern is the error, because uh, if you measure any instruments, basically what we can do it, there are the some standard value and there are some true value. So in the measurement, what we try to got this true value as equal to the standard value. So basically, if there is a difference between true value and its standard value, then the difference is called the error. So it can be minimized by selection of appropriate measuring instruments. For example, if you want some measurement, so first we decide what type of instruments are used for the measurement and what are the measuring method. These measuring methods and equipment depends upon the quantity to be measured. So error can be avoided by, and then that is the first step. Second, if you want to avoid the error, we require careful planning, education, and evaluation of the experiment. So first by selection of the instruments, then by the selection of the measuring instruments, then as careful planning, execution, and evaluation make our measurements error free. Then we have moved to the what are the performance characteristics of the instruments. So it is the one of the characteristic for selecting the most suitable instruments. I am already so that for a particular measurement we have required to select the particular instruments. So we know that characteristic of the selecting the most suitable instruments for a specific measurement job. Two basic characteristics are static and dynamic. It means a performance characteristics of the instruments is static and then the dynamic. Okay, then we move to the what are the static characteristics. The static characteristics of the instruments are in general considered for instrumentation which are used to measure the an unvarying process condition. Just remember that we used to measure an unvarying process condition. In the case of static characteristics, all the static performance characteristics are obtained by one form or another of a process called calibration. there are the number of related definition. So similarly, a second definition of the static characteristic is the set of criteria defined for the instruments which are used to measure quantity which are slowly varying with time or mostly constant. And it mostly constant that do not vary with time. That's why it is called static characteristic. In the previous definition, we are using a word unvarying process condition. So there are a number of the related definition which are described below, such as accuracy, precision, repeatability, resolution, error, sensitivity, etc. So the first definition is instruments, a device or a mechanism used to determine the present value of the quantity under the measurement. For example, if we go to the market, we purchase some packets, any quantity, so that quantity is written on this packet, and we accept this what the quantity reach. If there is written that this packet have the 300 gram, because we know the what is the standard value of 300 gram, so we accept it. So instruments, a device or mechanism used to determine the present value of the quantity under the measurement. Then what is the measurement? The process of determining the amount, degree or capacity by comparison, direct or indirect, with accepted standard of the system unit being used. Because we know, if you purchase a particular packet and the mention that this packets have 300 gram, so we know that this 300 grams, what is the standard value of this 300 gram, and if you want to measure, we are easily verify by any shops. If they have the instruments is available, and with the help of these instruments we are able to verify, so we accept that this packet have actually 300 gram. So that is called the measurement. So accuracy, the degree of exactness of the measurement compared to the expected value. For example, in the packet we have write 300 gram, but if we measure this particular packet, we found 280 gram, so there is error of the 20 grams. So that define the accuracy. So instruments is a device or mechanism used to determine the present value. Measurement is a process of determining the amount, degree or capacity by comparison, and accuracy is degree of exactness of a measurement. Then we move to some other definition. Resolution, smallest change in the measured variable to which an instrument will respond. We have very important quantity, the resolution. In the, for example, we are using analog instruments. So if there is a only 10 gram or 5 change in only 10 and 5 gram, we are not able to indicate on the display. But in the case of the electronic instruments, even in change in the 1 gram, we are able to display. So that is the basically called the resolution. Smallest change in a measured variable to which an instrument will respond. Then there is another quantity that is called the precision. Precision is basically a measure of the consistency or repeatability of the measurement. For example, as a particular again I give the same example. We pick a packet and we measure this packet from the different instruments. If its value is same, that is called the precision, but its value will differ, it means our instrument is not instruments have low precision. So a measure of the consistency or repeatability of the measurement is called precision. So precision is the consistency of the instrument's output for a given value of the input. For example, if you use a voltmeter for measuring of the voltage, so we know that the standard value of the voltage is around 220 volts, and if we measure with the help of the voltmeter, we measure and we got around the 210. So there is the two probability: one, the voltage is low voltage, and second, my instrument will not respond. So if you use this particular voltmeter to measure the voltage at a different node point, a different location, and we found a different value, some case 210, then 211, 212, then there is the precision of this instrument is the poor, and we need to improve the precision. So that is the basically meaning of the precision. Then our expected value, design value, we know what is the 1 kg. Similarly, we know the what is 1 meter. So that is the design value. If we know the 1 kg, so we compare each quantity to the 1 kg because that is our expected value, the design value, the most probable value that calculation indicate one should expect to measure. Error, the deviation from the true value and the desired value. True value is something and the desired value. So the desired value is actual expected value. But in the measurement we got some different value. So the difference of the desired value minus true value is called the error. And then the sensitivity, the ratio of change in output of the instrument, so the change of the input or measured variable is called sensitivity. So these are the basically parameter that is called static characteristics of the measurement. And in this way we have defined what are the errors in a particular measurement. So basically in the measurement there are two types of the error. First is the absolute error and second is the percentage error. So absolute error is the nothing but the difference between the expected value and measured value or true value. So we have take the expected value xe and measured value is xn. So xe minus xn. Then the percentage error, absolute value divided by the expected value. See, the absolute value is the basically absolute error divided by expected value. Expected value. So in terms of accuracy again, then the percentage, in terms of the percentage we have take the percentage of this particular quantity. In this example 100 minus error, that is called the accuracy, or we calculate accuracy and multiply by the 100, it should directly give the percentage accuracy. So what is the accuracy? Degree of the closeness to which a reading approaches the true value of the quantity to be measured, that is called accuracy. It means how much our measured value is, how much closer to the expected value, that is called accuracy of the particular instruments. So then we have a study about the different type of the static errors. So the static error of the measuring instruments is numerical difference between the true value of a quantity and its value as obtained by the measurement. That is, repeated measurement of the same quantity gives different indications. Types of the static error are characterized as the gross error or human error, systematic errors, and random error. So the first we have studied about the gross error. So these errors are mainly due to the human mistake in reading, or in using instruments, or error in recording the observation. It means it's cover actually a human errors. So human error is error during the reading or using or recording. We are reading the value of the particular measurement, and we have introduced some error. Similarly, we are using an instrument in the wrong way. Third, in the observation of particular reading, we have committed some mistakes. So that's these types of error is called the gross error. The gross error is also of course due to incorrect adjustment of the instruments and computational mistake. For example, we are doing some calculation mistake, that is called the computational mistake. Initially we have not adjusted the instruments, its pointer is not indicating to the zero, so that also introduced the error. So this error is called the gross error. We cannot be correct it mathematically because it's basically mistakes. So these all about the gross error. Then we move to the complete elimination of the gross error is not possible because it is basically the mistakes. So we are not possible to eliminate this, but one can minimize them. Some errors are easily detected while others may be elusive. One of the basic gross error that can occur frequently is the improper use of an instruments. The error can be minimized by taking proper care in reading and recording the parameter. It means when we are going to use a particular instrument, first we adjust the instrument properly, check all its parameter, then if you are taking any reading, read it properly and very attentive way. Similarly, during if you record some reading, also record in a very proper manner. Then, in general, indicating instrument change ambient condition to some extent when connect to a complete circuit. One should therefore not be completely dependent on one reading only. At least three separate readings should be taken. That is basically a general guideline. Ambient condition in a particular location affect our reading. So to avoid to minimize the gross error, we take more than one reading and can take the average of this reading, so the gross error will automatically reduce. So these are the basically some of the method to remove the gross error. That end of the today lectures.